In 2018 there were two major projects that we worked on, and one was totally redefining the way we build the sails. So it has to do with the sail construction, and I'll come back to that, and this resulted in some big reduction in the weight and in the feel of the sails. And then of course the second big project where we spent a lot of time was the foiling development, where we developed the carbon foils in collaboration with the F4 company, and then we did also our own aluminum G10 version. The way we are building 2018 sails, it's that we pre-make our so-called base material, and this is the Dyneema reinforced very lightweight scream, which about 2 mil thickness. Dyneema, it's used as an ultimate ripstop material. It's totally UV resistant and extremely strong. And then we take that base and we laminate onto it specifically pre-cut internal pieces. And these internal pieces are again cut on a plotter, and they are part of my design. So every piece, it's size specific and the sail specific. You will see them reinforcing the upper leech, the head, clue, so not only main areas of the sails, but actually they are everywhere. What this allowed me is to use panels which will have, let's say, thickness up to 10-15 mil at the stress areas, and then just taper down to only like 3 to 4 mil in the areas where there is no load or no demand. So in the end you actually get even stronger sail, because where there is a stress you have stronger material, but lighter in the end, because you don't have to carry this thick material everywhere in the sail. All the wave sails and the freestyle sails are using this construction, so just check it out, feel the material, and you'll see it yourself. The key design feature we found on the foil sail, it's to have a profile that it's really deep in the front, very far forward, and the sail that remains very, very straight and flat through the back section. It allows you, when you get hit by the gust, you actually start accelerating and you can just lean forward. The sail will be pushing the nose of the board down, and you actually get this massive bursts of acceleration, versus sail that it's fuller in the back. You actually have nothing but to open the sail and then lose the speed, lose the trim. So that's the key of this key design feature for the foil sails. So I'd like to explain a little bit what we did with foils and how the development went there. With the carbon foil, as I mentioned before, for us what's clear, we want the best, the fastest there is. That there was nothing, no compromise on that one. At the time we looked into it, was clear that F4 foils were the best performing ones on the market. They were really winning races. They were pioneering the high performance windsurfing foiling in San Francisco. And so we hooked up with these guys and got a really good collaboration going with Chris and Al from F4. And they helped us design, they actually did a design work for us for the Neilpryde F4 version of the foil. You can see the foil, it's co-branded. And what it is, what I'm really proud, it's actually another evolution of F4 design, which was at the time the best there is. Differences that we worked on was we focused on increasing the stiffness of the mast to the maximum possible, so it's totally full 100% carbon. There is no foam inside. It's a solid carbon mast made in pre-preg technology in really high-end steel molds, so we can use huge pressure for closing the molds, unlike aluminum that always deforms and you just can't put as much pressure on them. We decided to keep single piece mast to fuselage connection, because that's clearly the stiffest, the strongest way to go about it. And it was clear for us that, okay, you compromise a little bit of the packed size, you can't break it down into very small pieces, but as I said, this is a high performance product and it can still easily fit on top of a board in a board bag, because still this is narrower than any board, so there was really no good reason why to make it break into pieces and compromise the strength. Now with the wings, we worked with Chris on a new wing design, and this is the new 80 cm wing because their development happened all in San Francisco. It's a very high wind. They're foiling mostly on 5.5, 6 square meter sails. Worldwide, foiling happens from now we are seeing as soon as 4 or 5 knots. Actually, the really good guys are already on the foil, and you can push it up easily up to 30 knots and so on. So we understood right from the beginning that the only way to really cover this without making compromises is to have a specific light wind / course racing wing, and this is our 80 wing, which is like the wing I would say would be primarily used by people. But then we decided that we want to make sure that this foil can go really fast as well when it gets windy, and this is why we are offering a small wing which is based 100% on the original F4 San Francisco so-called wing. No? So this is like a really high-speed wing that can make over 30 knots of speed already. Then the other big feature, which is a departure from the F4, and it's also I think it's I'm sure it's actually unique on the market. It's a so-called bayonet type of the rear stabilizer connection. So the rear stabilizer enters into the fuselage and it's held by 4 screws. The 2 side screws tied and allow it to pivot up and down, and then the 2 screws top and bottom allows you to actually very fine adjust the angle of the rear wing. And this is extremely important. This is how you trim your foils for weight, for the wing strength, for the stability. Basically what you want to trim the foil to be when you are sailing off wind, that you can just control the up and down movement, because this is the hardest to control it off the wind. And then you know that you will have the minimum drag when you are sailing crosswind and upwind. So basically you normally with tilting this wing, that the back wing always creates downforce. This is all lifting force, this is the downforce, it's a stabilizer. The more this is pointing down and more downforce it's creating, the foil it's more stable, but of course it has some more drag. So this is the thing, you want to trim it to have the minimum necessary downforce that you need. And this will depend, as I said, from the sail size, from the sailor size, skill, of course, lots of different factors. From development of our carbon foils, what we learned it's that number one thing, it's the stiffness of the whole system, that's the key. So what we decided it's to design the aluminum extrusion to be used as our mast on the aluminum foil, to be as large as we could fit physically into the tuttle box. Then for the connection in between the board and the mast, after different samples we tried, we realized that by far the best it's to actually directly weld the CNC based onto the extrusion, and this makes for totally play-free, strongest, lightest connection possible. Now same thing in between the fuselage and the mast of the foil on the aluminum. You will see normally most of the time 2 bolts used, but we opted again for another step, and we are actually using 3 bolt connection for the same reason, just to be as strong as possible. The bolts are really generous sized M8s in titanium material, because it's the only material that offers the strength, the corrosion resistance. I mean, there is nothing better than it for the application. When we worked on the wing designs with Dave, we looked into the wings that are a little bit lower aspect ratio than what we are using on the carbon wings, and this makes the foil a little bit less twitchy, so when you are changing the direction, it doesn't have a tendency to dive into the turn, so it makes it more forgiving. And at the same time we are sharing same profiles used on the carbon foils, because this is a very nice profile that has a very consistent lift over wide range of the attack angle. So this means that you can actually adjust your attack angles and really trim the lift to the speed and to your weight and stuff. The other feature on the design of the aluminum foil and the wings we did with Dave, you will notice the way how we managed to integrate the start of the fuselage into the top of the wing. So there is no fuselage protruding forward of the leading edge, which makes for a much cleaner entry, which is more efficient. Plus it keeps the fuselage length to minimum for the given span. And for the wings, we opted for a G10. G10, it's it is more expensive than other technology. We could have molded wings or so, but we decided that G10 is the material that gives us, first of all, extremely accurate reproduction. So all the wings are really perfect. They are CNC machined one by one. And the second of all, they are virtually indestructible, as you know, with the G10 fin. So even if you run into something or so, you can just resend it a little bit and you are good to go. You know, it can't split, it can't, so it's bulletproof. One thing what I would like to bring up, and you will notice that even our full carbon foil, I would definitely not say it's a light product, and that's because it's a really solid carbon. So as I said, what we learned, the by far number one design criteria on the foils, it's to make really as stiff as possible. Like any flex, any movement actually results in loss of control, in wobbly feel and stuff like this. Important thing when talking about the weight to realize is that foils are submerged under the water, and the actual influence of weight difference, it's very, very marginal, because you are just looking the difference in buoyancy. So the actual force pulling you down or up, it's absolutely marginal once it's under the water. Clearly the aluminum setup will be easier to get you going, and that's because it's less twitchy. You know, like the best way I explain this, it's like when you are riding a carbon foil, it's almost like a bicycle. You know, you have this active stability. The faster you go, the more stable you are. And of course it's challenging to learn that way. While the aluminum foil is just really stable even at the lower speeds and stuff, so it's much less demanding. And funny enough, it's really not much slower. It's like I think you really need to get to a certain level to really start getting full advantage of the carbon. And then after you come there, of course, that's the one to have, no? If you are serious about racing or something, then there is no question, no?